In this lesson, I'm going to discuss how to make an air column resonate. There are two types of air columns: a column of air contained in an open tube or a column of air contained in a closed tube. An open-ended straw or a trumpet or wind chimes made from pipes would be an example of an open tube. A closed-end tube, one end is closed and the other one is open. Examples could be a bottle, a pan flute, or a wine glass. Now here is a bottle. This would be a closed end, and if I blow across the top, what I can do is I can make the air column inside vibrate. What's happening is when I blow across the top, I'm actually drawing some of the air out of the bottle, but the air stretches kind of like a rubber band. It doesn't want to remain that way, so it snaps back in. So it moves back and forth in and out of the bottle a little bit. Here's a glass. I can make the air column inside the glass vibrate by tapping the glass. The glass vibrates and it vibrates the air inside the glass. Now, here are two bottles, a small one and a large one. What do you hear? Two different sounds. What do you think the reason between the two different sounds is? Here are two straws, a short straw and a long straw. What's the difference in sound there? Now, how is that sound produced? Well, here I have a diagram of an open-ended tube. Both ends are open here. And I'm using this as a model to explain how the air vibrates inside that tube. What happens is in dead center in the middle of the tube, the air molecules don't really move that much. And the reason for that is the surrounding air molecules on either end of the tube push hard on the molecules in the middle. So the molecules in the middle don't really vibrate that much, and that constitutes a node. A node is where the wave, the material which is vibrating in the wave does not actually move. In contrast to that, on either end, that's where you have an opportunity for the air to move in and out of the tube. So you get maximum movement of the air particles at the opening of a tube. So in an open-end tube, maximum movement. In a closed-end tube, maximum movement only occurs at the open end. And if we were to sketch a wave to represent how those molecules move, we would end up getting a wave that looks something like this. In the middle, we have the highest compression, and another word for compression would be pressure. Just a reminder, wave speed of air, we're talking about air vibrating inside the column. At 20 degrees Celsius, it has a speed of 341 meters per second. In contrast to that, the wave speed in a string is not 340 meters per second. Generally, we know that waves travel faster in solids than in air.